Hi guys, welcome to this video on another measure of data spread, and this time we're discussing the quartiles. So the quartiles, as the name suggests, split the data set into four equal parts or four quarters. Suppose we have the student data set we used earlier. This appears on the table on the right side. I've also ordered it for you. And I have laid out the mark column horizontally in this row as well to make it easy to read. Now then we know that the median of this data set of this row splits the data into two halves. If you're not sure, watch the previous video on median. So here 3, the number 3, which is given in bold right in the middle, is the median value. And you can pause the video and verify that half the data is below 3 and the other half is above it. So there are 5 data points below 3 and 5 data points above it. So therefore, the median also has an additional special name. Since it divides the data into two halves, it is called the second quartile, or Q2. Now let's focus our attention to the first half of the data that is below 3, that comes before 3. Yeah. This data is below the median 3, so the first half contains 5 elements. And let's try to split this half as well. So to split this half, we will take yet another median. But this median will be the median of only the first half. So the median of the first half is called the first quartile, or Q1. As you can see, it splits the first half into two parts. So the first quarter of data falls below the first quartile. Similarly, we take the upper half of the data and find its median. The median in this case is the value 4, which is given in blue color. This median of the upper half is called the third quartile, or Q3. As we can see that when it splits the upper half into two parts, 3/4 of the data falls below Q3. You can verify it yourself by pausing the video, but below this blue 4, 3/4 of the data lies. This is why it is called Q3, or third quartile. So to recap what we've just learned, the quartiles split the data into 4 equal parts. First of all, we take the median value, which splits the entire data set into 2 equal parts, and hence it is called Q2, or the second quartile. Median of the data to the left of Q2 is called Q1, or the first quartile, whereas median of the data to the right of Q2 is called Q3, or the third quartile. Remember, if an odd number of data points exist in the data set, then median is just the middle value, because there is only a single middle value. Otherwise, the median is the average of the two middle values. Again, all of that has been discussed in detail in an earlier video on median values. If you're not sure, you can watch that video. Now here's another set of definitions to remember about quartiles. Remember, to compute quartiles or median, we first sort the data. Then within the sorted data, if n equals the total number of data points, then Q1, or the first quartile, exists at position number 1/4 of n plus 1. Remember, this formula only computes the position of the first quartile, not the value of the first quartile. Once we work out the position, we go in the sorted data set and find out this position, and the value sitting there will be the first quartile. Similarly, Q2, also called the second quartile, or the median of the entire data set, exists at position number 2/4 of n plus 1. which is the same as 1/2 of n plus 1. Finally, Q3 or the third quartile exists at position number 3/4 of n plus 1. So 1/4, 2/4, and 3/4 of n plus 1. Isn't that easy to remember? So once you understand quartiles, computing the interquartile range or IQR is very easy and straightforward. It is simply Q3 subtract Q1, or it is the distance between the third and the first quartile. The distance covers the middle 50% of the data. Just watch the picture at the top. Now, the distance from Q3 to Q1 excludes the most extreme data. That is data above Q3 and the data below Q1. Hence, it gives the spread within the middle 50% of the data. Let's now see an example. Now, this is the same student mark data set that we have seen before. The maximum and minimum marks are again marked for you, while we computed its quartiles earlier on in this video. So let's compute the IQR or the interquartile range for this. This is Q3 take away Q1, which equals 4 minus 2 and which equals 2. If you don't remember these values, skip back about 4 slides in the video and refresh your memories. So IQR becomes equal to 2. Note the IQR, unlike the range, is not impacted by a single outlier 14 at the end of the data. When we computed range earlier on, it was maximum take away minimum, and the answer turned out to be 13. We showed that how simply changing the maximum value from 4 to 14 increased the range significantly, even though the remaining data was quite close to each other. The IQR, in contrast, is only 2, which shows that it still better represents the closeness of the majority of the data than the range. So this concludes the discussion on the quartiles. We'll see you in the next video.